Welcome to Science Today. What we need to discuss today is what causes the seasons here on Earth. Why is it that sometimes it's freezing cold and snowing outside, and other times it's really hot and you want air conditioning and everything? So that's our big question for today. That's what we need to get into. So the question of the day: what causes the seasons? Just what we were saying, and the answer simply is the tilt of our axis. And that's what we need to get into today. What in the world does that mean? If you don't know what causes the seasons, by the end of the period, hopefully you'll know. All right, so let's jump right into it. You've got the question, you've got the answer. For the picture, just draw anything that has to do with seasons, maybe a snowflake or sunshine or a leaf or something like that, that helps you think of, those changing seasons that happens. Okay, vocabulary word, quick, that we got to take care of at the beginning here. Believe it or not, we have not done the definition for planet so far. So you can flip on over to your vocabulary where it's planet. The definition, it's just a large celestial body that's orbiting a star. That's all that there is to it. So it's a really big chunk of, in our case, rock, gas, water, and Earth. But remember, there are the different kinds of planets, right? You got Mercury, big chunk of metal, basically. You've got gas giants out there, right? But all of them, they're orbiting around a star, right? That's the definition for it. There are some technical things, clearing its path, right? That's the big problem with Pluto. It's got to be big enough so that it's got, it's compacted itself down into a circular and some things like that. But all we have to worry about is basically it's a really big thing spinning around, a star. So for an example, put whatever planet you happen to like best, right? For a non-example, something that's not a planet, the star perhaps, because you need a star to have a planet, but that's not the definition that we're having in there. Okay, joke of the day. What would you call a tick on the moon, right? If there was a tick on the moon, of course you would call it a lunatic. Oh, yes, it's that bad. All right, seriously though. Let's see. I think this is the only other vocabulary word we need to get into today is satellite. Same thing. We've been talking about some of this stuff for a while now, but the definition, right? Celestial body, code for something floating around out there in space, of course. But it's orbiting a planet, right? So while the planet is the thing that's orbiting a star, it's a satellite, it's orbiting a planet. There are literally thousands and thousands of examples of these. You could pick up the Hubble Space Telescope or any other satellite that you might happen to know about. For a non-example, something else that might be floating around out there could be a meteor, right? That we talk about with small stuff in the solar system, right? So that's the definition for satellite. And then one quick note is there is a lot of satellites out there, right? So if it's all that it is to be a satellite is something orbiting a planet. Well, here's a map actually from NASA, right? And this is just the space stuff, junk, if you want to call it that is orbiting Earth. And these are all the things that they're tracking. So it means it's the larger things. This is not counting a lot of the little tiny things that are out there. Obviously, the size and color, that has to do with how big the thread is. But often if NASA is going to send something else up into space, they often consult a map, similar to this one, trying to determine, okay, where is stuff that we know about that's in space right now, so that it's not causing problems bumping into other things. So there is a lot of stuff out there. I mean, oh my gosh, that's just mind-boggling right there. Okay, but the main event of today is the seasons. What's causing those seasons to happen? Well, let's first talk about what's not happening, all right? It's not the distance from the sun, right? Because look at this. If we measure it in the summertime, right, we are 152 million kilometers from the sun, roughly speaking. But in the wintertime, look, we're only 147 million kilometers from the sun. I mean, no wonder, right? That makes totally no sense in my head because you would think, okay, in the summer it's got to certainly be closer to the sun to make us warmer, in the winter further away. But it turns out the difference of a few million kilometers, it really isn't enough to make a difference temperature-wise for us, right? So the difference between the two, it's pretty similar. I mean, you'd have a hard time measuring the difference. Certainly we can't tell just by looking at the sun in the summer compared to the winter, with our own eyes. You can't tell the difference, right? So it's not the distance that's causing it. What's causing the seasons is the tilt of the axis, right? So if you remember, we talked about axis really quickly earlier. You've got to imagine it's kind of like this little demo that I have right here, where there's a stick that goes, that's a gross sound right there. right? That goes through the center of Earth, right? Now, there's not really a stick going through the center of Earth, but if you imagine that, that's where the Earth is spinning, right? The Earth is kind of spinning around and around and around on that little stick. Now, in relation to the sun, though, our axis is not going straight up and down like in this picture. It's actually going to the side, kind of like this guy. There we go. It's actually on an axis. Our axis is actually at an angle, compared to where the sun is. So what that means is, if the sun kind of is up here and it shines on Earth, well, look, its rays kind of go, directly from where the sun is. And in this case right here, they're tilted down and they're warming up more towards the southern side of the planet, right? Because the northern side where we live, well, in this case, look, it's kind of pointed away from where the sun is. So it's not that we don't get any sunshine. I mean, look, like right there. Okay, look, there it was. We got a little sunshine. And then it comes up another day. Right there, we got a little more sunshine. But we spend most of the day actually, in darkness. That's why in the wintertime, it's dark for such a long amount of time and everything. But fear not, because 6 months later, we've spun all the way around the sun. Our axis is still here. But look, now the sun's on our side of the planet over here. So now what happens is now this top part, the top part of the planet that's tilted now towards the sun, that's the part that's getting heated up, and that's where we are. And that's why there's a long, long part of the day where it's sunny, and then at nighttime it's relatively quick in the summer, right? And so, we've got more sunlight in the daytime and very little darkness at nighttime, right? And so that is what's causing the sun or the temperature to rise. It's kind of like a tater tot in the oven, right? The longer it's in there, the warmer it gets. If you take a frozen tater tot, put it in the oven, I don't care if the oven's like 500 degrees. If it's in there for 1 minute and you take it out, guess what? That tater tot's still frozen, right? It's kind of like us in the wintertime. We only got like a teeny weeny bit of light for a few minutes, right? But if you take that tater tot and put it in an oven for a couple hours, yeah, it's going to be a crispy crunch, right? And that's us in the summer, right? If we're in the sunshine day after day for long, long hours, well, you get sunburn. You better get the sunblock out and stuff like that, because eventually everything starts heating up, right? And that's exactly what's causing those seasons to happen. Let's see this short little video explaining the same thing, maybe a little better even than I can.
You know that Earth orbits the sun, right? And that it takes a full year for our planet to complete its orbit. Earth also rotates like a slightly tilted spinning top. Earth remains tilted in the same direction all year round as we orbit the sun. But that means the sun's light shines differently on Earth at different times of the year. Let's look at Earth when it's winter in the northern hemisphere. Observe how the North Pole tips away from the sun. This means that sunlight strikes the northern hemisphere at a shallow angle for a short period of time. This is why winter weather is generally cool, with short days and long nights. As Earth orbits the sun, we move towards spring in the northern hemisphere. Now Earth is tilted neither toward nor away from the sun, as day and night are about equal in length. As we make our way to the summer months, notice that Earth is still tilted in the same direction, only now on the other side of our orbit. The North Pole is tipping toward the sun. Sunlight strikes the northern hemisphere more directly, and the sun stays in the sky for a longer time. Compared to winter, summer days are warmer, and the sun stays in the sky much longer. Notice, too, that while it's summer in the northern hemisphere, it's winter in the southern hemisphere. Because of Earth's tilt, the seasons are reversed. We observed how Earth's tilt creates the different seasons throughout the year. How does this affect life? Plant life and other photosynthesizers, we call them primary producers, depend on sunlight. They respond to the changes in the seasons. Earth-orbiting satellites measure the amount of carbon dioxide absorbed by these primary producers. Bright regions on this map show where they devour the most carbon dioxide, turning light from the sun into oxygen and natural sugars. In spring, when sunshine strikes the cold waters of the North Pacific, productivity skyrockets. Phytoplankton and other microscopic photosynthesizers form the base of the ocean food web, and all ocean life responds to changes in the seasons. On land, forests grow green during the spring, brightening the continents. During winter, continents in this view turn dark from a lack of photosynthesis.
Cool, right? Okay, so let's see here. We get to let's skip that part. Okay, so let's get to the work that you need to do for today. All right. You can go over to pages. Well, this year at least it's 57 and 58. It might be slightly different depending on what year you're in for us. But this page right here, we're going to call it page 57 right here. All that you need to do is it's trying to show you the difference between summer, fall, winter, and spring for where we live in the northern hemisphere. Right, all the time you have sun, it's always shining on Earth. The difference is as the sun or as the Earth goes around the sun, right? The difference is what part of the Earth is basically tilted towards the sun because that axis is there, right? The axis stays the same, but its orientation changes 4 times as it's going around, the sun. So for us in the summertime, right, that's where we live in the northern hemisphere, and it's pointed right towards the sun. In the wintertime, right, the tilt is the exact opposite of that. So where we live, right, it's basically, we get sunshine, don't get me wrong, but we're not getting very much of it on the top, right? A lot of it is, going down towards the southern hemisphere. Then in the fall and the spring, well, then it's basically equal for us, right? The sun is pointed basically straight at the equator at the center, so it's equal, summer and night or daytime and nighttime, in spring and fall, and that's why those tend to be the more mild seasons temperature-wise for us, right? So all you need to do is kind of shade in blue and yellow where it's the sun is shining for us. The other side, or the next page, 58 this year, is all you need to do is fill in how would you describe that happening, right? So over here is kind of the visual version for those visual learner people. Here you need to describe it, right? So remember, it's the same thing. In the summer, for the northern hemisphere, sun is shining on the northern hemisphere, or on the northern hemisphere where we are, right? For fall, basically equal, amounts of sun and nighttime, for us. Winter, right? Southern hemisphere is getting most of the sun. Northern hemisphere only gets a little bit of sun. And then springtime, same thing as fall, right? Equal amounts of light and darkness, right? So that's what you need to do for those 2 pages. Next thing you need to do is the reading, right? So chapter 6, section number 7, right? Again, this year it was pages 62 to 63. It might be slightly different depending on what year you're in. But reading 6.7, that's the, read those. You need to highlight at least one important fact in each one of the paragraphs. Then if you go into Schoology, you should have quiz 6.7 that you can work on, right? So that's, that's the last thing that you need to work on for today. All right, hopefully that helps you out.